Hello, welcome to Math 1324. This is Chapter 10, Section 2, Example 1. In this example, we want to talk about function transformations. Now, there are going to basically be three types of function transformations that we're going to talk about. The three types are translations, what does my math lab call them? It's not translations, it's shifts. We also have stretches, and we have reflections. So those are the three types of transformations. And all of them are kind of displayed here in this equation. Now, what we're going to assume is we're going to say let y equal f of x be the original function. And what you can do to that is any of these right here. Now, I'm going to go ahead and let me change that to a smaller one. There we go. That and that right there. They're both outside of this function right here, which means that those are actually going to affect the y values. And since they affect the y values of a function, what they do is that makes them vertical transformations of some sort. Now, notice that one of them is multiplication, one of them is addition. The multiplication is a stretch, the addition is a translation or a shift. So what we would think of that as is a vertical stretch for A and a vertical translation, in other words, a vertical shift for D. So A tells us a vertical stretch, and D tells us a vertical translation or a vertical shift. Now, basically, for anything that's vertical, do what it says. So this A out here says A times whatever's happening here. So what we would do is we would multiply all the y values by A. But here's the thing, with multiplication, if you're multiplying by a number greater than 1, that's technically a stretch. But if you multiply by a number between 0 and 1, in other words, a decimal that you might think of, that makes it actually a vertical shrink. It's still a stretch by a factor of whatever it is, but that's pretty much it, yeah. Anyway, same thing with the plus d. If it says plus 2 up at the very end, we just add 2 to the y values. And of course, we still do all of this in the order of operations. So we always do the multiplication first and then the addition or subtraction. Next, let's talk about these two. Now, those are inside of the function. So the inside, that makes that horizontal. It's directly associating with the x. So for both B and C, those are both horizontal stretches and shrinks, and also translations. So with a horizontal stretch, though, we always do the opposite. And with a horizontal translation, we always do the opposite. So this right here is actually the standard form for a translation, okay, specifically for translation. And notice that the number in front of x always needs to be a 1. And if it's not, then we have to put it in this form by factoring out whatever number's in front of x. So that this b, whatever it is, we have b times all of this. But because it's on the inside, since it's horizontal, we do the opposite. So up here, it says multiply by b, that means that we actually divide by b. Same thing here, it says subtract c, so we would actually add c. And this is all to the x values because this is going to be horizontal. Now, that actually means that numbers between 0 and 1 for the b values will actually be a horizontal stretch, actually. But a number that's greater than 1 would be a horizontal shrink because you take 8 divided by 2, you get 4, right? So you actually go to a smaller number. But if you take 8 divided by half, that actually gives you 16. So if you have a number that is between 0 and 1, you're actually stretching, whereas a number greater than 1, you're actually shrinking. It's a little bit weird, I know. We also have one more thing that can happen, and those are the reflections. If A is negative, that is a reflection across the x-axis. Now, why is it a reflection across the x-axis? Well, let's just say we have a quadratic. Okay? And if a is negative, we actually take that a, multiply every y value by a negative. Let's say it's negative 1. And what that does is it changes all the y values to be negative. And so your new function would look like this. Notice what's happened though. This function is now reflecting across the x-axis to the other side, which is the reason why if a is negative, it's a reflection across the x-axis. However, for b, if it is negative, that's a reflection across the y-axis. Because the x values are changing. So if we have, quadratic won't be easy to see. If we have that right there, if we're dividing by -1, that means that all the x values are changing to the other sign. So this would look more like this. And so there you go. That would be the reflection across the x-axis if b is negative. Now notice though that if you have a quadratic, if I reflect this across the y-axis here, that is actually its own reflection. So sometimes negative doesn't really change a whole lot if it's in front of the b. Okay, now that is pretty much all of the transformations that we're going to see. I kind of just wanted to deal with this in the sense of more of a generic idea behind all of it. In my math lab, you're not going to be asked to specifically say vertical stretch, vertical shrink, horizontal stretch, horizontal shrink, vertical translation, horizontal translation, or a reflection. Now, at least in this section, in 10.3, in 10.4, and 10.5, we may, but for now, in this section, we're not going to be asked to. But this is just the idea of function transformations. Alrighty, well, I'll see you in the next video. Have fun.